All right, last Friday we ended up finishing on valence electrons. And we said that if you look at an element or an atom, it's got two types of electrons. It's got the inner shell electrons that aren't very reactive, and then valence electrons are always in the outer shell. And we said that they're typically occupying these orbitals of defined shape. So some electrons reside in s orbitals, some reside in p, and you can only fit 2 electrons in each orbital. And then we went along and talked about the quantum model, basically saying that you can only fit 2 electrons into each orbital. If you're running out of orbitals in that same energy level, you have to go up to a higher energy orbital. You can't be in between. And then the trick for determining valence electrons. And then we finished up talking about charged atoms. What we need to finish up with is reviewing the periodic table briefly. So let's pull up our notes for that. And when you look at the periodic table in our classroom, it doesn't really have these color-coded charts. I like the ones that are color-coded because it outlines the important elements of the periodic table. There's a few main areas I really want you to remember. First one is group 1. If you remember that video I showed you, the Brainiacs video where they blew up the bathtub, this is referred to as the alkali metals. These all are very reactive, tend to be quite explosive when you put them in water. And does it get more reactive as you go up or down the column? Down the column, right? So I think they stopped with rubidium, which they said was like a depth charge in a bathtub. All right, the next one that we have is the group right next to it in red. This group is called the alkaline earth metals. Quite a few of these are found in geological systems. So like calcium carbonate is found in limestone. It's made of primarily calcium. And calcium carbonate is a natural base that occurs in our ecosystem and actually helps regulate the pH of a lot of freshwater aquatic systems. That's why it's called alkaline earth metal. All right, and then over here on group 7, this is another important one. These are called the halogens. Halogens are very common in organic chemistry, and we'll talk more about this later, but they tend to be quite electronegative. And then at the very far end, group 8, we've got these ones that are called noble gases. And these are elements that tend to be quite unreactive. They just like to be on their own. And then the last one that I want you to know about is the center block. These are called transition metals. So those are the main areas of the periodic table I want you to know about. If you look at this one too, it has additional groups. I don't really care if you know about those additional groups, just these main 5. All right, the tricky thing too is a lot of students will look at the periodic table and they notice this block down below. It just kind of seems separated out. The reason that they do that is for practicality. The better way to draw the periodic table is with that group kind of squeezed in between group 2 and the remaining groups. So in order to make the periodic table a little bit more square-like, they just cut that out and say, see bottom. But in reality, if you look at the periodic table on ours in group 3, you see those blank boxes. That's where they should fit in. So they just do that for the ease of printing out periodic tables. All right, a couple more things. One thing I refer to often when I'm looking at the periodic table is the group. And if you remember, a group is something like 1A, 2A, 3A, etc. Whoops. And these are always arranged in vertical columns. And as you saw in the Brainiac video last week, anytime you have atoms in the same column, they tend to have very similar reactivities, right? And then the other interesting thing is that they're also all arranged so that they all have the same number of valence electrons. This is different than a period in the periodic table. A period is a horizontal row. So if you look at the periodic table, the numbers on the far left-hand side are the period. So period 1's for hydrogen and helium, period 2 is for lithium, beryllium, boron, and so on. And in this case, they have radically different reactivities. And then they have increasing number of protons as you go left to right. So make sure you don't mix up period and group. Typically, when we're discussing atoms, we're more interested in the group because of the similar reactivities. Periods aren't used that often. All right, a couple of last things regarding the physical properties. In general, the periodic table is classified into 3 different groups. First group is metals. Next one is nonmetals. And then the last one is metalloids. All right, does anybody want to share some physical characteristics for metals, just day-to-day metals that you run into, like steel, aluminum, iron? They're shiny? Yeah, exactly. What about with electricity? Are they good at moving electricity around? Yeah, absolutely. So we call these conductors. And that's usually the case, not always the case. All right, another term that you might not be familiar with is malleable. What does malleable mean? Does anybody know? It can be shaped, right? So if you take, let's say, a piece of gold, you can actually hit it with a hammer and flatten it out. You can't do that with a lot of nonmetals. For example, if you try to do that with charcoal, which is a nonmetal, it just pulverizes, right? You're not going to actually flatten out charcoal. Okay? It also conducts heat well. So for example, if you touch a hot pan, it's going to hold heat for a long time, right? What about its density? Is it going to be high or low? Yeah, so large density. All right, and nonmetals, on the other hand, are not always solid. So for example, helium and hydrogen, neon, argon, all of those are gases. They're not solids. Any of the red items on the periodic table in the classroom, those are all gases, not solids. All right, they're not typically as dense. At least relative to metals. They are poor conductors. Of heat and electricity. However, this is slowly changing. I'm going to put a little asterisk down here. How many of you have heard about like carbon nanotubes or graphene? So those are really big in the news lately. Graphene is basically an infinite sheet of carbon atoms that are all linked together. The Nobel Prize was awarded a few years ago to the scientists that were studying that, and what they're finding is that some of these nonmetals like carbon can actually be excellent conductors of electricity. And so what they think is maybe in the near future, our electronics will be made of nonmetals rather than metals, which is nice because a lot of the metals that we use in electronics are precious metals, right? And most of those precious metals that we have in our electronics are really hard to recycle. So when you throw away your iPhone, there's gold and silver in there. It's really hard to get that back without ripping apart the phone. If we can make it all with nonmetals, all of a sudden the environmental footprint's a lot lower. All right, metalloids basically means in between. So it's got properties of both. And if you remember, when we look at the periodic table, the metals, for the most part, are going to be the transition metals. That's that block in the middle. And then the alkali metals and alkaline earth metals on the far left. So usually the metals are on the left-hand side and the very bottom. The non-metals are group 3A, 4A, 5A, and over for the most part. Makes sense? All right, I think that's where we're going to stop today. If you can, try to grab all three of the handouts. We're just going to do all group practice today. So try to do this as much as possible without your notes. If all you do is have your notes open, you're not really going to learn much, and you might not know what to study between now and the exam.